mechanical from the College of Engineering, Gindi. He is a recipient of numerous awards throughout, had published extensively, and holds about 18 patents. Along with them, we also have other co-PIs joined in this webinar, Professor Shankar Krishna Pillai, Professor Sundar Rajan Natarajan, Professor Saurav Rakshit, and Professor Piyush Shakya. And they are the co-PAs of and leading this project. And yes, it is my pleasure to invite them all to this webinar. So before we start, a note to the participant, please use the Q&A box to enter your questions and upvote your question that may interest you so that the moderator can prioritize them. Over to you, Professor Jnanamurthy.
Thank you, Rudra. On behalf of IIT Madras, I once again, it's my pleasure to welcome you for this webinar. Share the screen. Okay, I hope everyone can see the screen. Okay, I'll give a brief about what are the research activities that is happening in this Center of Excellence. Okay. This is the Center of Excellence on Architecture, Materials, Design and Manufacturing, with a target towards the next generation electric vehicles at high speed ride. Okay. Myself, Jnanamurthy, is a principal investigator, and we have Professor Shankar Krishna Pillai, Professor Sundar Rajan Natarajan, Dr. Saurav Rakshit, Dr. Piyush Shakya, all the colleagues of mine who are working in the machine design section of IIT Madras. I'll give a very short brief about what is it architected materials, because the terminology may be new for some of you. Okay, I just start with a simple example. Okay, a well-known application. So I just shown here in a brake pad. Okay, most of you might have very much familiar with this. And if you look into the requirements for the product, okay, it's very complicated. Okay, it is not like another products. It's so complicated that the material should have a very good coefficient of friction, very high thermal conductivity, very good wear resistance, and a very good high temperature strength. Okay. Now, if you look into these requirements, it's impossible to have one single material which will satisfy all these requirements. Okay. Some materials will have a very good friction coefficient, but the same thing may not have a very good high temperature strength. So what we do so far for this is we have different proprietary combinations developed by leading industries. Some combinations are excellent for road and something are very good in the rail applications. And it is always a composite, needless to say. We have metal matrix composite based brake pads. We have ceramic composite based brake pads. Then we have polymer matrix composite based brake pads also. All are composites. Okay. And we mix nearly about 10 to 15 ingredients to get these requirements, and it is homogeneously distributed in this material. Okay. In this architected material approach, we should not get confused with composites which we are very widely using. Okay. So here we try to selectively reinforce the requirements, what is expected in an application, because you know metal has its own capabilities. Okay, easy to deform, it can absorb a lot of energy. Okay, a good thermal conductor. Okay, and polymers light in weight, good friction capabilities. Ceramics excellent high temperature strength, and all these things are entirely different class of materials. Most of you are engineers and you are very much familiar that the processing capabilities and functional requirements of all these things are entirely different. And now we are trying to see how best we can try to bring these different materials in a macro level in a product so that the best things in each is effectively utilized in the component. Okay. We are not getting into the composites. We are getting into an macro reinforcements selectively in the product, depending upon the requirements of the product, so that we get the best in everything into a product. Okay. This is the area what we have started in around 2006 onwards. You can see here, most of you know the functional requirements, what is needed in the case of the Tooth is quite different than what is needed in the hub region. So we need a high strength material in the low transmission portions, but not that much is needed when we want to have a required dimensions. So we started investigating using injection molding process to develop very different type of materials in a product. Then subsequently, we started our research in these network-based composites. Here we try to take metal, foam, fill it with a suitable resin depending upon the functional requirements. And then we try to understand how these kind of composites try to behave in a certain functional requirements. And this example, as I just mentioned, we also do, we have done some research work in this brake pad performance. Okay, we have done a lot of numerical studies to effectively reinforce with a different class of material for certain function, which I will brief it in a subsequent slides. Okay, so the architected metal approach is macro reinforcement to get the selective properties in the selector region. Although I have just shown certain examples here, this can be applied to any applications, depending upon the functional requirement, depending upon the need of the material to satisfy the overall performance in a certain period of life cycle of this component. We need to do these reinforcements accordingly. What we focus in our group is architected materials design and development is one key area. We need to understand what kind of products require what kind of functional requirements as an independent, as an individual product. Then our team members are very good in numerical tools and design optimization to properly select the reinforcements to do the effective function. And we also look into develop some simulated products. Sometimes it will be difficult to develop a very big size products and do the validation. So we like to do it in academia, whatever way is possible. Although this can be applied to multiple domains, okay, now we like to focus in two critical areas, which is of importance for Indian society: electric cars and then the high-speed rail. Okay. And our focus also is on the making the components lightweight. You know, in the mobility sector, whatever you want to improve, okay, the lightweight is always the first requirement. Okay. And then sustainability. It's going to be very important for the automotive sector because we need to reduce the carbon footprint. How to use the natural materials in the next generation mobility. And we also try to investigate some specific issues associated with the electric vehicle traction motors, which is a key component in these applications. So what is needed to pursue research in this domain? It is a translation research, as most of you can understand. We need to have a good knowledge on the product design. We need to understand how the brake pad is designed, or every component is designed. A sound mechanical engineering knowledge is needed. Then accordingly, we need to have the selection of materials. Now it is a choice of thousands of materials available, and then we need to select the best ones. Then a good information about the manufacturability of the materials is needed. So to carry out research in this domain, we need to have experts who are good in the design with equally good knowledge in the materials and the manufacturing. Otherwise, a real product will not come out. Okay. So the current members, as you can see in the website, okay, we have the experts in these domains, okay, design optimization, numerical analysis, and then reliability studies. We collaborate with our colleagues who are close to Chennai. Then international associations currently involved are with the Nagaoka University of Technology and Kinda University of Technology. which is ongoing, and we are open for many more international collaborations and then repeated collaborations within India too. And needless to say, this requires a lot of expertise and experts like our moderator and others. Experiences are extremely important. So we have good association with NSK Bearings Japan. They give their practical problems, what kind of solutions are needed, what are challenging kind of things, and advices from Dr. Satya Prasad and his team. Then associate from the Japan Railways. A consultant is also helping us to arrive at identify certain components which will help, which the team will look into as a part of the research. I'll just brief about some of the ongoing research activities, okay, to give a glimpse about what is happening here. Okay, so this work is done by some of the postgraduate and then PhD scholars, okay, who are acknowledged here. And this is a conventional brake pad. I think most of you are familiar. We just do, in one slide I am briefing, plenty of work is done, and you can see some of them are already published. Okay, we try to look into the one important aspect of how best we can dissipate the heat. Okay. Now the demands are very high. We always want to fly fast. Okay, we want to run, drive fast. Okay. So the brake has to absorb a lot of energy, and it has to dissipate it. And it has to, we don't want to change the brake pads in every 2-3 years. We want to have it as long as possible. So one of the critical elements, we try to look into different possibilities of having a metallic heat dissipation units, done some sort of a numerical simulations and arrived at this places where and all heat is going to get generated, and modeled it, optimized it, and then we try to understand it using the numerical tools and optimization tools, and find out the best metal insert, which will not influence my friction characteristics. In the meantime, we'll try to dissipate the heat so that the life of the brake pad will be very high. Now, there are challenges also. It's not a very simple. Okay. Now, we are trying to put the two different class of materials in a macro level. It is not a micro constituents. In the conventional brake pads, if you see, the particles will be in terms of hundreds of microns. But right now, we are looking into macro kind of reinforcements, depending upon the customized, selectively reinforcing it. So when we get into the macro size reinforcements, there are many challenges. One to say is the thermal expansion. So we need to select an insert so that during its operational sequences, it should not result in a damage of the components, because thermal expansion, how it's going to play on the heat dissipation, what will be my, without damaging the other parts. And these are all the critical issues. And then we need to carefully choose the dimensions, considering the operations, considering the temperatures and other environmental effect that will result in a dimensional changes. So some of the activities are just shown over here. We try to investigate about different combination of the materials and then possible thermal expansion, what should be the clearances, which clearance is better, and kind of thing. Okay. And another area which is ongoing, which is close to this topic is traction motor bearings in the electric motors. Okay. And also in the high-speed railway. Okay. What is close to that? Okay, probably some of you may think why you are choosing in these two domains. Okay, so both are run by the different types of an electric motor. Okay. So that is the reason I have just given in the topic. Okay, the future mobility means we need lightweight structures, and then in this new sector, our drive is going to be mostly some type of a drive motor, depending upon the brands. They have different types. Okay, and one of the critical elements in the drive motor is the bearings. Okay. So if the bearing is damaged, then it's going to create a lot of noise sometime, and the vehicle itself will not move. So one of the critical elements is the bearings. So we have a lot of bearings in conventional IC units, driven automotive also. Okay. But if you try to look into that, the sound generated, the noise levels generated in the other parts are very high, so the bearing noise becomes negligible. But when it comes to an electric vehicles, we know that IC units are not there, and any small sound generated from very, very minute damage in the bearing is going to play. So now our group is also trying to understand when the current flows in the bearing, what is going to happen what will happen to the reliability, damages, and subsequently the noise generated. We try to understand the contact characteristics, because the bearing is a very critical element. It has all kinds of motions. Okay? It has a contact fatigue. It has a simple sliding in some parts, fretting in some parts, and all kind of relative motion is taking place. And it is running at very high speeds, and it is a critical element. Okay, so bearing fails means that the whole vehicle is down. So now we try to understand the reliability of these materials, these bearings under the combined mechanical and electrical loads, which is expected in the drive motor. So, as I just mentioned, different types of current flows depending upon the drive motor and its control units. Okay, and the most critical thing is the lubricant in the bearing. Okay, so this is going to get damaged, okay, or it will not do its intended function. So we'd like to understand not the complete bearing, of course. Okay, we are trying to understand what is going to happen in these kind of contacts under the combined electromechanical load. This is a part of one of my MS research scholars, okay, and he has studied in a different electrical loads, and you could understand even in a very, very short time. It is not a complete bearing testing. It is a simulated condition under the worst operating conditions. So we try to understand that the coefficient of friction is going to get increased even in a very short duration of about 1,000 meters or something. Now imagine you are using these bearings for many, many years and then thousands of kilometers. Then you can anticipate how fast you can expect the failures. Okay. If it is going to be a pure sliding, but it's not going to be that. That's going to be we are doing all this research in accelerated conditions. The contact temperature rise in a very short duration is significantly high. Okay, so this results in the damage of the lubricant. Okay, the lubricant will lose its function, and a lot of research is done in the leading industries on the type development of different material combinations, which will withstand this electromechanical loading, and also the lubricant research is done to make a lubricant which is going to survive for a longer duration. Okay. We get support from NSK bearings who supply the samples and other things for our research. So now one way to prevent is there are multiple attempts. Okay, it's done by electrical engineers and mechanical engineers and other set of people also. How to make sure that the current is not flowing through these bearings. One attempt is to give a coating. Okay. This is also attempted in the leading bearing manufacturers. And then we try to understand numerically right now, and then we try to develop something also in the due course. What are all the parameters which will influence this insulation characteristics of the bearing? Okay. So now we try to model with a different kind of combinations of is it a pure numerical solution? Okay, then try to understand what kind of porosity levels will try to be much better, both from the insulation requirements and also from the mechanical strength. Okay, it is not only the insulation requirement; mechanical strength is extremely important. We did a lot of numerical work on different levels of modeling different boards, and then try to understand how these things are going to influence the coating is made with a different porosity gradients, or we can also try to make it with a different kind of architected coatings to make sure this multiple requirements of electrical insulation and then the mechanical reliability is achieved. This is the type of what we are also doing in this center of excellence. Okay. So we wish to study the different contact characteristics expected here under the sliding, rolling sliding, and in the case of threading, try to understand both numerically and experimentally what type of coatings will be preferred for these applications. Okay. This is another topic which is so selective reinforcement is another terminology. We try to use it over here, and then one of our scholars, they have completed a doctorate in this domain. Okay, so how to effectively and selectively reinforce to cater certain requirements. Okay, so we try to study how this metallic foams, when you can reinforce in certain places wherever you want to dissipate the heat, how best it's going to do it. Okay, we did both experimental and numerical work, and then we observed that the significant heat dissipation is happening when you are going to reinforce it with a metallic force compound with a particle reinforcement. Okay, this is a type of work from this aspect. Of course, we can do it, this kind of reinforcement for different functional requirements so that the best of the class of the materials is achieved. Okay. So we are also working in this hydrogen cores. Okay. So it is a proton exchange membrane fuel cell, PEMFC. Okay. So in this case, we are mostly looking into the mechanical aspects. We are not working on the chemical and other aspects. Okay. Once the component is made and then if it is put into the service, what is going to happen? Okay, what is going to happen if it is going to run for about a few years? Okay, whether the intended functions will not get lost or something like that. Okay, so one of the key components here is these components which are shown over here. Okay, so these components are normally made with graphite plates. Okay. And then now we are trying to look into the alternatives to the graphite plates, and a group of people are working with different kind of metallic foams. Some group of researchers, because it's an active area of research and a lot of work is done. And we try to understand if a metallic foam is used, this is the nickel metallic foam, if it is used in the fuel cell, how long it will do its job. Okay. So we try to do some sort of a numerical studies, okay, and then try to understand, okay, what kind of relative motions are going to happen due to the vehicular vibrations. Now imagine you are not always riding in a smooth roads, there will be ups and downs. With these things, what is going to happen to the reliability? Okay. So now we try to do both numerical, we just modeled these forms and then try to understand what kind of relative displacement is going to happen between the forms. Okay. And then with the other materials. So what happens is, just imagine if these things are going to run for about few years, then you are going to have a problem with the performance of the components associated. Okay. So we try to both try to simulate the contacts using simulated experiments, okay, micro contact simulators. Then we try to do it and find out what kind of debris are going to get generated, what's the approximate size of the debris, how it's going to contaminate, and how this contamination is going to influence the performance of the fuel cell. Okay. So this is a fuel cell is a very critical component, as most of you know, and you are not going to replace it in every 1 or 2 years. It's going to be there for about at least 5-6 years, or do the entire duration of the vehicle. Okay. So during the entire duration of the vehicle, all this contamination should not clog the critical components, should all diffusion layers should not get clogged and all kind of thing. Okay. So that will influence the performance or the efficiency of the fuel cell. Okay. So a few research scholars are working trying to find out how this metallic foam, how they change its characteristics with the clamping load, operational characteristics, how it can be modified with selectively redesigning the foam such a way that you get a best out after the clamping and during the service kind of thing is research work which is in progress. Okay. And now the sustainability is a very important aspect. Okay. So the whole world is looking for alternative materials which are decomposable, okay, and then it is environmental friendly. So how then we are also thinking that instead of looking into the synthetic materials, polymers, why don't we try to look into the natural materials? Okay. In South India, most of you know that there is a plenty of coconut usage, and then tons of materials are disposed as a waste, and it mostly goes as an landfills. Okay, it is huge hills you can see in certain parts of Tamil Nadu, and then it is also there in Sri Lanka. And from these shells, which are currently not well utilized, we get two important byproducts from this waste. Okay, so one is of fiber, another is a pith. Okay, so how effectively we can convert these natural materials? Okay, plenty of research is done in this natural fibers, jute, banana, and sisal and bamboo on developing and polymer composites in the synthetic resins, and then people have studied about the performance. But we are trying to look into the product-centric translational research. How best we can use our architected design compass concept into a product development, and then try to use our natural materials so that the sustainability is achieved. So we are looking for applications in these domains, because here is one of the important areas where significant CO2 emission is still happening. Okay, and then this research is focused towards that. Right now, only limited research is done in automotive. Okay, and then we like to collaborate with the leading automakers so that we can focus towards development of their products. Okay. Our association is strong with these 4 universities currently. We have decades of experience collaboration with Nagaoka University of Technology, and we have joint supervisions, joint student exchange programs, and other things very actively going for last 2-3 decades. Okay, now with this more possibilities of collaboration, we like to enhance it with Nagaoka University and different universities all over the world. Okay, and we are getting associated with the Kinda University also, and then IIIT and Conchita. Okay, and we get a lot of advice and support from automakers. One is NSK Bearings, and then the group of researchers from the Ashok Leyland. They are trying to advise us to give what direction should be we can do it. And we are also interested. Soon we'll have more collaboration with people who are from the National Taiwan University and then others. Okay. And we are looking for more industry collaboration. We like to have more industries in our team so that our research will be more useful to the society. Okay. Because the topic is going to be more. It's not a very generic topic. We are not just generating the materials and trying to understand mechanical properties kind of thing. Okay, so we like to look into the product and try to see how best we can build the product with a certain combinations of the materials for its effective performance. So it is a product centric. So that means an industry collaboration is extremely important. And needless to say, okay, we want to expand our collaborations with reputed institutes within India and outside India. We like to have a lot of research collaborations. Even in this domain, we have 2-3 research scholars jointly supervised by faculty members outside India. And we like to organize periodically workshop and training programs. We are open for new collaborations too. And we like to have individual agreements if needed to, because these are all very sensitive areas. Okay, based on the industry, we like to go with a professional way of managing with them, non-disclosure agreements and other kind of required documents. Okay. And currently about more than 15 research scholars and postgraduate scholars are associated in different activities. I have just shown certain things in 1 or 2 slides, but each area is what's discussing for about a few hours. Okay, and then we have 2-3 staff members. We are working in this topic. So this is the core team. Okay, we have Dr. Myself Jnanamurthy. Okay. We have Professor Shankar Krishna Pillai, is in doctorate from Oxford. Is expert in then optimization. Okay. Then we have Professor Sundarajan Natarajan, is a faculty in our section. He is a PhD from Cardiff, and he is an expert in the numerical simulations. We have Dr. Saurav Raksit, he is excellent in design optimization. Okay. Then we have Dr. Piyush, industry experience, and then he's a PhD from IIT Delhi and working on the health monitoring of mechanical systems. Okay. And then we have today the moderator who is giving a lot of advice to our team in the different aspects of product development and then useful research. So this COE is established with the support of Ministry of Human Resources and Development. Now it is called Ministry of Education, MOE. The old name most of us are familiar is MHRD. Now it is Ministry of Education under the Government of India. Okay. And we all know that, as given in the introduction, institution of eminent status was given for IIT Madras, and the project is supported as one of them. So now I like to thank all the participants for patiently listening. You can interact through our moderator, and then you can also contact any one of us through email for further collaborations if anything you need to do. Thank you once again.
Okay. Can I go ahead, Professor?
Yeah. Yes, sir.
Okay.
Yes.
Welcome. I think when I look at the participation of 225 people, it is showing how much industry is hungry for new technology. And certainly, I am very happy to be a moderator here. And what Professor Jnanamurthy and his team has presented is nothing less than exciting. It throws open a lot of possibilities, coexistence of physics, development of an ecosystems that transcends several facets of engineering. Taking the mindset from a deductive approach, you make a casting, machine things out of it, forging, machine things out of it. But this is more of an additive approach. It removes us from the traditional Euclidean approach of prescribed geometric shape to an evolutionary approach. It gives a whole new meaning to the factor of safety because it is very tailor-made that you have to redefine the factor of safety and failure modes. Naturally, it forces the researchers and the users to be more intimate with the functioning of the component. In other words, it takes optimization to the next level. And certainly, my hearty congratulations to the gutsy work of Professor Jnanamurthy and his team of illustrious colleagues. It is quite interdisciplinary in nature, as I could see. We have moved a long way from talking about homogeneous isotropic material, then to orthotropic material, composites, sintering, metal matrix, and more recently 3D printing. This is actually leapfrogging from all that and giving architected material that essentially rises to the occasion on how precisely it should function. Certainly, it will lay the foundation for smart, intelligent, sensory materials. So I am very, very excited with what this team is doing. Certainly, they have my fullest support. And, naturally, we have certain very interesting questions. Let us start with Mr. Rajaganesh, who said, what are the scope of architectured material and possibility of using that in engineering? I think a very nice way to start the Q&A session. And may I request Professor Shankar Krishnapillai, who is into design dynamics and optimization, to throw his views on the scope of architectured material and the possibility that it throws open in engineering. Dr. Pillai.
Hello. Yeah. This is Professor Shankar here. Can you hear?
Yes, we
are
could
able to
hear
hear
you.
Shankar. Yes.
Okay. So somebody has asked this question: what is the scope of architectural materials in engineering? So it has a very wide scope. Professor Jnanamurthy has showed one particular part relating to mechanical design, but it has a lot of scope in other areas like vibrations, other product development also. Also, it is tied up with the 3D printing and additive manufacture, because many of these architected shapes are not easy to manufacture by the conventional manufacturing process. So you need to have the suitable development in the 3D printing. And also, I earlier mentioned that it has a lot of applications in the vibration field also. Okay, so you can look at examples like packaging materials. Okay. Packaging materials need to absorb a lot of vibrational energy. Now the tendency is to use some polyurethane foam, okay, which absorbs a lot of this vibrational energy, but the mechanical properties are not good because it's a soft and flimsy material. Okay, so with this meta-material concept, you can make a packaging material which is not only good at absorbing the vibration energy, but also stiff. So like Professor Jnanamurthy said, you can have the reinforcing material there inside. And at the same time, it should have the good energy absorption properties. And important fact is that you need to have the topology optimization algorithms also to develop these type of materials, because you need to run this algorithm so that it can come up with a particular type of geometry, like some lattice shape, and with a certain material in a certain lattice, and another type of material that is multi-material in another lattice, which is good at absorbing the energy and at the same time give the stiffness.
Excellent. I think, Dr. Krishnapillai, you have given a fantastic overview pretty much whatever Professor Nyanamurthy has presented, you have very succinctly encapsulated it in a couple of minutes. I think there is a much better understanding. With that, I would like Professor, Saurav Rakshit to talk a little bit about the next question, which deals with traction motor. The question is, what are the ideal characteristics of a traction motor? Why is traction motor used? Which traction system is best? I think this has been told in the context of electric vehicle. And maybe, Professor Rakshit, you could throw some light on that.
Yeah, this is multiple types of traction motors are used, Professor Satya Prasad. And the thing is, each one has its own drawbacks and other things. So we cannot say this is a particular one, another thing. And now it is, I don't want to name certain companies. Okay, so a set of popular automotive company, they use BLDC motors, and some of them they are using AC induction motors. Each one has its own advantages and disadvantages. Okay. So it is a huge topic to be. You cannot say this is better than that or something like that.
Absolutely. Very nice. Good. I think, certainly the characteristics of traction motor is very, very application specific, and that's what is going to propel the vehicle. Which brings us to the next question. I'm not sure if Professor Sundararajan is there, but if we could, if he or Professor Piyush could throw light on membrane electrode technology, MEA, in PEM fuel cell, about which we got to listen. Any thoughts on that, please? If Professor Piyush or Dr. Sundararajan is there, he could speak. Otherwise, I would request Professor Nyanamurthy or Professor Shankar to throw some light.
What is the question, Dr. Satya Prasad?
It is about membrane electrode assembly in a fuel cell.
Yeah, see, if you look into the very popular type of fuel cell which is used in automotive, is a PEM fuel cells. Okay. So we have many critical components in the PEM fuel cell. Okay, and the whole thing is going to be each plate is going to be in terms of 1 or 2 millimeters. So one of the critical elements which I have not shown here is your graphite plate, which is very widely used nowadays. Is a bipolar plate, which is one of the critical elements. We know it is made of graphite. So the problem is graphite is excellent for this application, but unfortunately mechanical reliability and fabrication cost is quite high. So our interest is to look into this PEM fuel cells, because this is the one which is most popular for the transportation application. There are many different types of fuel cells too. Okay, and we are more interested in looking into one particular part, which is the critical and which looks for an alternative once. Okay, there is a graphite plate. I have removed the picture of the graphite plate. If you can look into that, it will have some sort of a different geometries of grooves were put into the graphite plate. And it is weighing, it's something around 3-4 millimeters thickness. It depends upon the brand and other things. And the critical issue with the graphite plate is when you are assembling these fuel cells, you are going to land up with some sort of a micro cracks generating, and then due to the vehicular load, it's going to create a more problem. And the one alternative is going with a metallic foam. And now people are working with different types of metallic foams, and we are looking into the nickel-based metallic foams, which are one of the competitive materials for these applications. And the people are also working in stainless steel plates, okay, not foam plates itself, as a replacement to these metallic foams. Okay. And now people are working with the titanium foams. Okay, so various alternative foams, because it will give a very good distribution of the fuel to the fuel cell for the group reaction.
Thanks so much, Professor. Okay. We have a couple of questions, but we have only 3 more minutes left. So I request the panelists to make it quick. The next question is, in future, electric vehicle may rule the world to reduce pollution. But the questioner says, how could we charge the vehicle in a sustainable manner without harming the environment? So he says that the electricity generated to charge the vehicle should also be green. Any views on that?
It's much better than your IC engines. You can one way, simple way. Okay. It's only a relative. We need to move. We need transportation. We need mobility sector. So, it is much better than IC engines. Okay. Now, in future, we are looking into something much better. So we are looking into this hydrogen cars. Okay. It is much more cleaner. Okay. So needless to say, the size of batteries and then number of batteries used is going to be significantly reduced in the case of hydrogen cars, okay, compared to the conventional electric vehicle. So there is plenty of savings.
Solve one problem at a time. Yeah, good motors, good batteries, and then we'll think about good electricity also. Yes. Which brings us to the last question. Is it possible that in the same way biodegradable materials like coconuts and are used, other waste that pose serious threat to environment like e-waste or different plastic can be effectively recycled? So the question here is that you showed us that we could use sisal and jute and all that.
Yeah.
The question is what about the current material like e-waste and plastics and all that?
That is a different. Yeah, that is an entirely a different domain. Okay, so recycling of plastics is something very, very important domain, and a lot of research is done. Okay, the major issue is if you try to look into the recycling of polymers, the issue faced by this international community is mainly how to collect that waste. Okay, the recycling is one issue after you collect it, but unfortunately, many things are just thrown away. The collection is biggest challenge if you look into the data produced. Whatever is collected, if you try to look into from that aspect, a majority is recycled. So the societal responsibility is very, very important for properly segregate and then put it. That will facilitate the engineers and the technocrats to develop a technology for recycling. Okay, needless to say, the recycling is plenty of research is done on recycling of polymers, segregation of the waste, and then trying to group into a particular kind of polymer. A lot of work is done on that. And then recycling is also a very, very important aspect. And it is a different domain of research.
Excellent. I think there is just one last quick question by Manisha Singh. Operating temperature of proton exchange membrane fuel cell. So you could give a very quick answer before we close.
I'm not able to. It's depends upon the size of the. Okay, plenty of varieties are there. Okay, I can say it is a matter of few hundreds, not beyond that. It's not very high tech.
It is a fairly cold fuel cell. It is not like the other one, which is a hot fuel cell.
Okay. So I don't think it will exceed around 100 degrees.
No, it won't. It's a pretty reasonable operating temperature. I think we have reached the 5:45 p.m. limit mark, and it's been very, very exciting. And to all the participants here, there are more than 200 participants. I think, IIT Madras, you would have just read in the news, is right now on the forefront of the institutes in the world. And no less, tribute to the illustrious faculty members there. I think this is a very ambitious effort by Professor Jnanamurthy and his team. And I would certainly encourage all my industrial cohorts to interact with this team, understand what is being done, the significance of it. Each one of you would be having technology roadmap, corporate plan. Sustainability report is also now mandatory along with the financial report. Therefore, there is a whole gamut of activities that this team is doing that would be relevant to what each one of you would be doing for your respective organization. And so, everything starts with curiosity. I would like to congratulate Dr. Jnanamurthy and his team again. And I think with this, I close the question and answer session and hand it over to the IIT panel here.
Rudra?
Yes.
Yeah.
Like, but if at all, Professor, if you want to continue to get more questions, you can even.
Probably we have shared our email IDs. Probably we'll get into through the email whatever questions when we'll back on.
Sure. So thank you, Professor. Thank you once again for delivering such a webinar to the participants, and for sure. And we have got more than 1,500 registrations, and then more than 300 plus participants and indeed to comment. It was a wonderful webinar that I was enjoying a lot. So thank you once again. Thank you, Professor Jnanamurthy. Thank you, Dr. Satyaprasad. And thank you, co-PAs. And thank you, participants. And thank you, Mr. Naresh, Ms. Lisa, and Mr. Shivram Prasad. Thank you. Thank you.
Thank you for a wonderful organization. And then thank you, Dr. Satyaprasad.
Thank you.
And all our co-PAs also. Thank you very much. So we'll be ready to have any connection to the email.
Sure. Mr. Naresh, you can please proceed for the closure of the session. Thank you.